Yeah, I welcome you for the series of lecture on metrology. Now, we will start module number 6 on screw thread metrology. In this module, we will be discussing about the general introduction to screw threads, covering the uh, thread making processes and how they are classified and what are the various applications of screw thread, those things we will be studying. And then we will also discuss about the various screw thread terminology, and then we will move on to the measurement of screw thread elements. In this lecture 1, we will be covering the general introduction to screw threads. We will cover general applications of screw threads and classification of screw threads, thread cutting methods and how they are designated. Then we will study the screw thread terminologies, various terms used related to screw threads, and then we will discuss about screw thread measurement, that is major diameter measurement, minor diameter measurement, thread angle measurement, pitch measurement and effective diameter measurement. Now, briefly we will try to understand the general aspects of screw threads. These are the most important machine elements and are used in screws, bolts, nuts, studs, tapped holes and other power transmitting devices. They are very convenient for joining and sealing purposes. They are used as coarse type for bracket fitments and as very fine type for micrometer heads and for precision moving mechanisms. It is basically a helical ridge produced by forming a continuous helical groove of uniform cross section on an external or internal surface of a cylinder or a cone. Now, you can in this photo we can see the helical ridge produced, and the cross section is uniform for all the threads. Now, a screw thread formed on a cylinder is known as a straight or parallel screw thread, while the one formed on a cone is known as a tapered thread. You can see here some tapered threads here. This is external tapered thread and this is internal tapered thread. Now, what are the general applications of screw threads? They are used for fastening purpose. Screws, nut and bolts and studs are used for temporarily fixing one part onto the other part, and they are used for joining coaxial joining of rods, tubes etc., by external and internal screws. And they are also used for clamping. They strongly hold an object by a threaded rod, as in C clamps, vices, tile stock on lathe bed. They are used for controlled linear movement, that is for travel of slides and movement of work tables in milling machine, shaping machine, CNC machine tools etc. And these screw threads, they are used for transmission of motion and power. For example, lead screw used in a lathe is used for transmitting motion and power, and they are also used for converting rotary motion to translation, that is rotation of the screw causing linear travel of the nut, which have wide use in machine tool kinematic systems. Screw threads are used for position control in instruments, screws enabling precision movement of the work table in microscopes are examples, and screw threads are used in precision movement of precision measurement of length, that is the threaded spindle of micrometer is an example for this. Now, to get the very slow rotation, we can use the screw threads in the form of as in the example of gear and worm wheel, and to exert heavy force the screw threads are used. Example is mechanical presses. The screw threads are also used in conveying and squeezing materials in screw conveyors, injection molding machines and screw pumps, and in controlled automatic feeding in mass production assembly, the screw threads are used. Now, let us study how these screw threads are classified. They are classified according to the location, that is whether the screw threads are made on the external surface as in bolts, or whether they are made on internal surface, for example nuts. These threads can also be classified according to the configuration, that is whether they are straight helical, for example bolts and studs, tapered helical as in drill check, also radial on scroll as in the self centering check. Screw threads can also be classified according to the direction of helix, that is whether they are right handed or left handed. According to the form, they are classified as V threads, normally 60 degree and 55 degree thread angle is used. Acme thread, wherein the angle is 29 degree, they are classified as square thread, which are generally used in power screws. Buttress thread, worm thread, like this, depending upon the form they are classified, and depending upon whether they are full circle or semicircular threads. So, semicircular threads are being used in circulating type of bolts and screws. According to the standard, whether they are BSW, British Standard Whitworth threads, or metric threads, according to the number of start, whether it is single start or double start or like this multi start screw threads. According to the spacing of threads, I can say TPI, threads, number of threads per inch, whether it is 6 TPI or 12 TPI, like that we can classify, and depending upon the pitch also we can classify. So, pitch is pitch or lead, it is the distance between two successive threads or length of travel of nut for one rotation of screw. So, pitch can be 1 millimeter pitch or 2 millimeter pitch or 3 millimeter, like that. According to the compactness or fineness of threads, we can classify them as general threads and pipe threads and very fine threads, which are used for leak proof applications. And according to the segmentation, whether they are full form threads or off turn threads, example is off nut used in lathe, and then sector threads, which are used in jaws of lathe checks. Now, how these threads are made? There are many methods. Very common method is thread machining. They can be turned, they can be milled, and thread grinding, thread tapping. So, these are some thread machining methods, and the threads can also be made by thread rolling operation. Now, let us move to the screw thread terminologies. Various terms are used in with respect to screw threads, internal screw threads as well as external screw threads. Now, this picture shows some of the terminologies. You can see the profile of the screw thread and the distance between one point on the screw thread to the corresponding point on the next thread. This is known as pitch, and then this peak portion of the thread is called crest, and in the bottommost, that is the lowest point on the screw thread profile is known as root, and then we have this sloping surface which connects the crest with the root is called the flank, and then the angle between the perpendicular line perpendicular to the axis and the flank is called flank angle, and double the flank angle is known as thread angle. Now, this is the pitch line. So, this pitch line it bisects the thread such a way that the thread material space is equal to the air space. So, this line is called pitch line, and this diameter is known as pitch diameter, and addendum. So, the distance between the pitch line and the crest point is known as addendum, and similarly the distance between the root and the pitch line is called dedendum. Now, pitch it is a distance from a point on a screw thread to a corresponding point on the next thread measured parallel to the axis. So, this is very important. When we measure the pitch, measurement should be made parallel to the axis. Now, you can see here this is a single start screw thread. So, wherein lead is equal to pitch. Now, what is lead? It is the distance a screw thread advances in one turn. When we rotate the screw thread by one turn, what is the distance moved, axial movement of the thread, that is called lead. For a single start, lead is equal to pitch, whereas in the case of two start screw thread, lead is equal to twice the pitch. Now, thread form is the cross section of the thread cut by a plane containing the axis. For example, in the case of metric thread, we will be having a V profile like this. So, this is the thread form or thread profile. In case of metric thread, this included angle which is known as thread angle is equal to 60 degrees, and in the case of Whitworth thread, the included angle is 55 degrees. And how these screw threads are designated? The metric threads, they are designated in this fashion. One example is shown here, M10 times 1. So, M indicates that the thread is metric type, and 10 indicates 10 mm major diameter, and this 1 indicates a pitch of 1 millimeter. Now, various thread forms are used in practice. This is a sharp V, wherein we have a sharp crest here. So, it is slightly modified, it is made rounded or flat, then it is called unified thread, and then in these two cases sharp V and unified, the included angle is 60 degree, whereas in the case of Whitworth thread, the included angle is 55 degree. And then modified square 10 degree included angle. These are modified square threads used in power screws, and Acme threads wherein the included angle is 29 degree. So, similarly, we have modified buttress and then knuckle threads. So, like this different thread forms are available. Now, what is the major diameter? We can understand from this diagram. It is the major diameter is the diameter of an imaginary cylinder coaxial with the screw which just touches the crest of an external thread. You can see here we have the crest points here and we have the crest here. So, the imaginary cylinder will pass over these crest points, just touches the crest of an external thread or roots of an internal thread. It is also known as nominal diameter. In case of internal thread, you can see these are the roots and this is the root. Now, the distance between root here and root at this place. So, this distance is minor diameter and distance between the crest to crest. So, this is a major diameter. So, minor diameter is the diameter of an imaginary cylinder coaxial with the screw which just touches the roots of an external thread or crest of an internal thread. So, this is also known as root diameter or core diameter. Now, let us understand what is the meaning of effective diameter or pitch diameter. It is the diameter of an imaginary cylinder coaxial with the axis of the thread and intersects the flanks of the thread such that width of threads and width of spaces between the threads are equal. So, this is the line which is passing through the thread profile and it cuts the flank such that the width of thread is equal to width of space. So, if you pass the line in such a manner, then that is called pitch line, and the from pitch line to the other pitch line on the other side. So, this diameter is pitch diameter, and flank is the thread surface that connects crest with root. So, the crest is connected with the root. This sloping surface is known as flank, and then the depth of thread, it is the distance between crest and root measured perpendicular to the axis of screw. So, the axis of screw will be somewhere here, and we have to pass a line perpendicular to the axis, and the distance between the root and the crest. So, this is the depth of thread. So, this is depth of thread. Now, angle of thread. So, angle, it is the angle between sides of thread, that means angle between two flanks measured in axial plane. You can see here we have a flank here, we have another flank here. So, the included angle between two flanks is known as thread angle, and helix angle is angle that the thread makes when with plane perpendicular to the thread axis. So, this is the thread axis. So, we have the thread axis here, and then this is the ridge or the thread. Okay. It makes an angle with this perpendicular. So, this angle is known as helix angle, and flank angle is of the included angle of the thread. And then we discussed about the addendum and dedendum. Then sometimes we say right handed thread. So, when the screw thread advances when turned clockwise, it is called right handed thread, and when it advances when turned in the counterclockwise direction, it is called left handed thread. Now, let us move to the measurement of thread elements. in order to find the accuracy of screw thread produced, it is necessary to measure the various thread elements. So, thereby we can say whether the thread produced is as per the specification or not. So, normally these are the elements measured to check whether the screw thread is okay or not. The measurement of measure diameter, measurement of minor diameter and measurement of pitch diameter or effective diameter, pitch measurement, thread angle measurement and thread form is also measured. Now, let us study how the major diameter of a screw thread is measured. So, this instrument is known as bench micrometer. We can see the very rugged cast iron base of the instrument, wherein there is a slide which can be moved parallel to the axis of the bench micrometer. This is a slidable body which houses the micrometer head. A large diameter micrometer is fitted and this is the anvil. So, when we rotate this thimble, the anvil moves in or out, and then we have a table. So, this table also can be moved in this direction to accommodate the work pieces, and this table surface is a flat surface which can be moved up and down again to accommodate the work pieces of different sizes. So, left hand side we have the body which houses the anvil. This anvil also can be moved in and out to accommodate work pieces of different sizes. We can see there is a fiducial indicator. So, when we place the work piece between these two anvils and we rotate the micrometer head, the anvil will move and then it will act some pressure on the work piece, that is transmitted to this anvil, and finally, it is transmitted to the fiducial indicator, and this indicator will indicate what is the pressure or force applied onto the workpiece. This is very essential to conduct the experiments, measurement experiments at the same pressure always. It is very essential that we should not over pressurize the screw threads. So, when the anvils when they should just touch the crest. If we over pressurize the screw thread, what happens is anvils will try to crush the crest and the screw thread gets deformed and we do not get the proper reading. So, to apply even pressure for all the work pieces, this fiducial indicator is provided. And on this table surface we can put some fixtures to hold the work pieces. Now, this shows a schematic diagram of bench micrometer. This is the micrometer head with the scale on the thimble and with the scale on the barrel, and then we have the measuring anvils and clamps for measuring anvils, fiducial indicator. The anvil and fiducial indicator it is slidable, so that we can accommodate the work pieces of different sizes. We can also see there is a fixture, holding centers are there to hold the screw threads. Now, it is very essential that the axis of these holding centers should be perpendicular to the axis of the bench micrometer. Now, in order to use this bench micrometer to measure the major diameter, normally the bench micrometer it is used as a comparator. That means, a standard cylinder, normally a plain plug gauge having approximately same diameter as the major diameter of the thread, to be measured is used as a standard cylinder for setting the micrometer, and over the standard cylinder micrometer reading is taken and it is recorded as R1. So, we use the standard cylinder to establish for a comparative measurement in order to reduce the possible errors, and then after taking reading R1, we have to remove the standard cylinder from the bench micrometer, and we have to insert the thread to be inspected between the centers, and again the micrometer reading R2 is noted down. So, using this bench micrometer, it is possible to measure the major diameter to an accuracy of plus or minus 0.001 millimeter. Such a fine accurate measurement is possible with the bench micrometers. Now, I can see here S is the diameter of the standard cylinder. Normally, plain plug gauges are used as standard cylinders, and R1 is the reading on the standard cylinder, and R2 is reading on the thread to be inspected, and then D, the major diameter of thread, can be calculated using this relationship S plus or minus R1 minus R2. Whether we use plus or minus, it depends on whether the standard cylinder diameter is greater than major diameter of thread or smaller than major diameter of thread. So, you can see here the measurement process. Initially, we have to take the measurement using standard cylinder, and the reading that is obtained is R1, and then we have to remove the standard cylinder, place the thread to be inspected, and then again you take the reading. So, this reading will be R2. And then we can conveniently use an outside micrometer also for measurement of major diameter. So, the care should be taken to see that the crests of the thread are not over pressurized. So, when we move the anvil, we should take care that as soon as the anvil just touches the crest of thread, we should stop the rotation of thimble. So, again procedure is same. Reading is taken with the standard cylinder, that is R1 we get, and then standard cylinder is removed and screw thread is placed between anvils and reading R2 is taken, and again using this relationship we can calculate the major diameter of the thread. Now, we will have a numerical problem. While measuring the major diameter of an external thread, a 35.5 millimeter diameter plain plug gauge is used as standard. The micrometer readings over the plug gauge and screw thread are 9.376 millimeter and 11.876 millimeter respectively. Now, we have to find the thread major diameter. Now, the data that is given is R1 is 9.376 millimeter. This is the micrometer reading on the standard cylinder, and then we have R2 is equal to 11.876 millimeter. This is the micrometer reading on the thread gauge screw thread, and then S, that is standard cylinder diameter is 35.5 millimeter. Now, in the measurement process of this type, normally smaller diameter standard is used, that is diameter of standard is smaller than the major diameter of screw. So, in that case we use this relationship D is equal to S plus R2 minus R1. So, the S value is 35.5 and R2 value is 11.876 millimeter and R1 value is 9.376 millimeter. So, the calculation will give us the major diameter of the screw thread as 38 millimeter. Now, we will move to measurement of minor diameter. The minor diameter is measured again by a comparative process. That means, we use a standard cylinder and we take the measurement and then we put the screw thread to be inspected, again we take the reading and then by using the relationship we calculate the minor diameter. And floating carriage diameter measuring machines can be conveniently used for measurement of minor diameter. The details about this floating carriage machine we will discuss after some time. So, use of prisms is made while measuring the minor diameter. These prisms, they look like small V pieces and they make contact with the root of the thread. The prisms are made of hardened steel and are made in several sizes having suitable radii at the tips. Now, you can see here these are the prisms. So, this is the prism being used on screw thread as well as on the setting cylinder. The prisms will look like this. So, the isometric view of the prism I have written here. So, this the sloping surface of the prism will not make any contact with the flank of thread as we can see here. So, this portion I am enlarging. So, this is the V prism and then we have a small radii here at the tip and then we have the screw thread profile. So, the sloping surface of the prism will not make any contact with the flank of the screw thread. The contact will be there only at the root. Now, using these prisms, we can conveniently measure the minor diameter of external screw threads. There is an arrangement in the floating carriage machine. There is an arrangement to place these prisms. Hooks are provided. Using hooks we can suspend these prisms and we can conveniently measure the minor diameter. Now, the procedure is similar to the measurement of major diameter. Reading R1 is taken with the standard cylinder placed between two prisms, and then standard cylinder is removed and threaded workpiece which is to be inspected is mounted between the centers of the instrument, and then reading micrometer reading R2 is noted down, and then using this relationship we can find the minor diameter of the thread. Again whether we use plus or minus symbol depends upon the size of the standard cylinder, whether it is the diameter is greater than the minor diameter or diameter is smaller than the minor diameter. Now, using this relationship we can find out the minor diameter of screw thread. Now, we will have a numerical problem here. While measuring the minor diameter of an external thread, a 30.5 millimeter diameter plain plug gauge is used as standard. The micrometer readings over the plug gauge and thread are 15.376 millimeter and 13.521 millimeter respectively. We are required to calculate the minor diameter, that is small d. Now, the data that is given is R 1 is equal to 15.376 millimeter and R 2 is 13.521 millimeter, and diameter of the standard is 30.5 millimeter. So, in this case a larger diameter standard is used, and minor diameter is equal to d minus. Since the diameter of standard is larger, we are using this negative sign. D minus R 1 minus R 2 is equal to, we have to feed these values, and finally we get the minor diameter, that is 28.645 millimeter. Now, we will move on to the measurement of internal threads. Let us understand how to measure the major diameter of internal thread and minor diameter of internal thread. The minor diameter can be measured by using taper parallels and also by using rollers. Now, measurement of major diameter of internal thread. So, for this we use a method called casting method. We can see in this diagram, this is the workpiece having internal threads whose major diameter is to be measured. Now, we have to take a replica of this internal thread. So, how do we get the replica of internal thread? You can see the arrangement. This is the workpiece with the internal thread. On both sides of this workpiece, like this, we have to keep wooden blocks, and then we have to pour either plaster of Paris or dental wax, or sulfur also can be used. We have to put the plaster of Paris mixed with water or dental wax into this cavity, and we should allow it to settle. And then once it dries, we have to remove the wooden blocks, and then we have to remove the solidified plaster of Paris piece without rotating the plaster of Paris. We have to just lift it. We should take care that while pouring the plaster of Paris, it is the so if this is the center of the workpiece, you can see the level of, this is the level of plaster of Paris. It is not crossing the center of or it is not crossing the radius of the workpiece. Such care should be taken, so that we can easily remove the solidified plaster of Paris. Now, this casting will have the thread profile, and then we using the bench micrometer, we can measure the major diameter of internal thread. Again, in the cast that is obtained, we should measure R 1 and R 2, and then we should use this equation to find out the major diameter. Now, how do we find the minor diameter of internal thread. For that two methods are suggested. So, first method is using taper parallels. This is used when the diameter is less than 20 millimeter. So, taper parallels and micrometer are used for measurement of internal thread. So, these taper parallels are pairs of wedges having rounded and parallel outer edges. So, when we look from this side, the parallels will look like this. So, they have a rounded edge. So, this curved surface will come in contact with the screw thread. So, like this. Again another wedge is used, a pair of wedges are used. So, again this is the rounded edge and this is the screw thread. Now, the distance between the outer edges of the parallels can be changed by moving them in this fashion. So, using this arrangement, internal diameter of the screw threads of different sizes can be measured. Now, using the micrometer, the distance between the outer edge, rounded edge is measured. So, that gives the minor diameter of internal thread. Now, using rollers or balls, we can measure the internal thread, minor diameter of internal thread. So, this is used when the screw thread diameter is more than 20 millimeter. So, precision rollers or balls are inserted inside the thread as shown in this schematic diagram, and slip gauges are inserted between the rollers or balls. So, these are the rollers or balls of same diameter. They are in contact with the internal thread, and the gap between the rollers or balls is filled with slip gauge. And then the minor diameter is calculated by adding the diameter of these two rollers plus the slip gauge width. Now, let us conduct an experiment to show the measurement of minor diameter of internal thread. Yeah, you can see a component having internal threads. You can see these are the internal threads. Now, we are required to measure the minor diameter of the internal thread. So, for this I am using two steel balls and slip gauge box. So, initially we should measure the approximate minor diameter using a vernier caliper. So, the approximate minor diameter as measured using a vernier caliper is 55, 56, 57, 58 millimeter, and then we have to add the vernier scale reading. So, it is 20th reading, 20th line is coinciding with the main scale mark. So, the vernier reading is 20 into 0.02. Now, we have to keep the two steel balls inside. We have to measure what is the diameter of steel ball. We can see steel ball diameter is 12 millimeter, and then we have to note down the vernier reading. The second steel ball diameter also should be measured to ensure that both are having same diameter. Again, you can see the the diameter is 12 millimeter, and then we have to note down the vernier reading. Now, we should measure the approximate distance between the two steel balls, so that we can easily build the slip gauge assembly. You can see the approximate distance between steel balls is 33 millimeter. And then we should see the coinciding division. Now, I am building the slip gauge assembly. And slip gauge should be filled between the steel balls. I am taking 20 millimeter slip gauge, 9 millimeter slip gauge, and then 1.006 1.005 millimeter slip gauge, millimeter slip gauge I am ringing, and then 1.23 millimeter slip gauge, and finally 1.006 millimeter slip gauge. Now, the assembly I am trying to insert between the two steel balls. So, it is not entering the gap. So, the width of assembly is greater than the gap between steel balls. So, we have to again reduce the width. Now, I am taking 1.001 millimeter slip gauge. I removed 1.006 millimeter slip gauge. Now, you can see it is entering. The assembly is entering in the gap between two steel balls. So, now this is the width of the slip gauge assembly, that is 33.231 millimeter. The total width is 33.231 millimeter, and then we have to add diameter of this steel ball and diameter of this steel ball to get the minor diameter of internal thread. Now, in the experiment we observed that ball diameter is 12.56 millimeter and gap between balls is 33.231 millimeter. So, the minor diameter is 2 times the ball diameter plus the gap between balls. So, finally, we get 58.351 millimeter. So, this is the minor diameter of internal thread. Let us summarize this lecture. In this lecture, we discussed about the different methods of making the screw thread and how they are classified and what are the various types of screw threads normally used. We also discussed about screw thread terminology, and then we studied about the measurement of major diameter and minor diameter of external screw thread and internal screw thread. With this, we will conclude this session. Thank you.